how's everybody doing out there? Well, hopefully everybody did a good job with our first set of hypothesis tests, which we did in 8.4. So now we want to move on to hypothesis testing where our sigma is unknown, or we're working with the sample standard deviation, which is similar to what we did with confidence intervals in 7.2. So if we look through our 4 steps, if you'll notice, there really isn't that much difference. So in step 1, everything's exactly the same because we're still working with means here. So step 2, the only difference we have here is since we know the sample standard deviation, we're using t intervals or t scores, tiger scores, instead of our zebra scores. So for these, I'm going to call this t sub t our test statistic. And then just like we had a comparison statistic, we're going to use that for this. But for that command, we'll be using inverse t to find our comparison statistic. And then when it comes to calculating our p-value, so again for these are pretty much exactly the same as what we had before, except for we're using t-CDF instead of normal CDF. So again, in our equals, not equals case, this is our two-tailed test. So notice we're going to have to divide our alpha up in between the upper and the lower bound for the two-tailed test. And then for our greater than or less than, these are both one-tailed tests. And so we're just going to use regular old TCDF, and then alpha will be in all of these areas, where in here, these are going to be our alpha over 2 for the less than or the equals, not equals case. All right, and then finally, drawing a conclusion, same as before. If p is less than alpha, we're going to reject h naught. If p is greater than alpha, we fail to reject h naught. So again, the only difference between this and what we did last time is we're going to be using t-scores instead of z-scores, and we'll be using t-CDF instead of normal CDF. So let's just go ahead, dive in, take a look at an example, and see how we do. All right, so for example 1, according to Mars, a typical bag of M&Ms contains 18 brown M&Ms. I claim that orange M&Ms is significantly different than brown M&Ms. I sampled 24 students and found the sample mean of orange M&Ms to be 18.5 with a standard deviation of 2.4. Can I conclude that orange and brown M&Ms have about the same number of M&Ms? So again, let's go ahead and write down everything that we need for this one. So the 18 that they're referring to is going to be related to our population mean that we're going to be using as part of our claim and comparison. So we sampled 24 students, so n is 24. We had orange M&Ms, a sample mean of 18.5 with a sample standard deviation of 2.4. And so we're trying to see whether they have about, orange and brown have about the same. So we are missing our alpha. There's no mention of an alpha in this case. So that means our alpha is just going to be 0.05. So remember, if they don't tell us, alpha is always 0.05. So from there, we should have everything that we need. So again, the word significantly different is going to help us with the claim. So that means we're looking at the equals, not equals case. So our H1 is going to be mu not equal to 18. Our H naught is going to be that mu equals 18. All right, so now we're ready to calculate our test statistic. So our T sub T, we're going to calculate first. So we take our sample mean minus our population mean, divided by our standard deviation, divided by the square root of 24. And so let me throw this in the calculator real quick to see what we get. Minus 18. Oops. Make sure, is it 18.4? 18.5, so good. Glad I caught it. 18.5 minus 18. Oops. Divided by 2.4 divided by square root 24. All right, so 1.02, let me check to make sure. All right, so I do have everything written down correctly. I just want to make sure I didn't make a mistake here. So it looks like our T sub t is going to be 1.02, our test statistic. So now we need to figure out our T comparison. So we need to figure out these two values, since this is a two-tailed test because of the equals not equals. And so again, since our alpha is 0.05 and we have a two-tailed test, then we're going to have to take our 0.05 divided by 2. And so our alpha over 2 is going to be 0.025. So we've got 0.025 at the upper, 0.025 at the lower. So if we're trying to calculate this lower one, we're going to do our T sub c is going to be inverse T 0.025. And then remember, when we're finding the inverse T, we're looking at degrees of freedom, not mean and standard deviation. So since our n was 24, our degrees of freedom is going to be 24 minus 1, or 23. So now, let's go ahead and type this in the calculator. Inverse T, 0.025, comma, 23. And so it looks like we've got negative 2.07 is going to be our lower comparison. So we've got negative 2.07 here, and then positive 2.07 there. And so finally, we're trying to see, does T sub t live inside of any of the blue areas, or does it happen to live in the white? So unfortunately for this one, T sub t is going to fall somewhere in this area. And if we remember, this is going to be our fail to reject, H naught. And our two blue areas are going to be where we reject H naught. So in this case, since we're clearly in the white, it looks like we're going to fail to reject H naught based on our graph. So now let's do our p-value and confirm that this is actually true in this case. So to do our p-value, we're going to do TCDF, our 1.02, and then some ridiculously big number. And then again, we're doing our degrees of freedom, so comma 23. And then since this is a two-tailed test, we want to multiply whatever answer we get from this by 2. All right, so let's throw this in the calculator here and see if this is less than alpha. So we've got our TCDF, 1.02, comma some ridiculously big number, comma 23, and then multiply that times 2. So we end up with 0.318 as our probability, which is not very unusual at all. It's actually 31.8%, so this could happen any given time. So this is much, much bigger than our 0.05 alpha. So this also says fail to reject H naught. So both cases we've got fail to reject, so it looks like we are going to fail to reject. So finally, to draw our conclusion, so we fail to reject H naught. There isn't sufficient evidence to support the claim that there is a difference between orange and brown M&Ms. All right, perfect. So again, I'm going to do like I did last time. There's only a few practice problems in this section, so I'm going to divide them up into multiple groups so people can kind of work together with other groups to verify that your answers are actually correct. And then if we come back in the next video, we'll be talking about hypothesis testing involving proportions. So good job, everybody, and I'll see you in the next video.